Okay, now to check that you really understood what I said, we will now push this idea. Instead of just using generate operators to handle different representations of the same data type, we'll now use it to handle completely different data types. And to do this, we'll do this thing called generate arithmetic package. Okay, so the idea is that we now want to work with rational numbers, complex numbers, ordinary numbers, as well as even polynomials. And we want to be able to do all these operations: add, subtract, multiply, divide. Okay, so this is what you saw just now, right? So you have this complex number package, and there's these operators that allow you to deal with either rectangular or polar. Okay, and essentially this is the sorts of function you see, right? As the data goes down, okay, it is stripped of the tag and sent to the correct package, and then when it comes up, data is retagged with the right tags. In generic arithmetic, we kind of generalized it. Just now you're dealing with complex arithmetic, so it's just this part of the picture. Now we go one level higher, right? We now deal with generic arithmetic. So that means that, okay, now the programs that you want to do add, subtract, multiply, right? They'll go down to your new package, okay? And then after that, based on whether it's a rational number, it's a complex number, ordinary number, you will go down to the next level. Okay, for example, if it's a complex number, you go down to this part here. And this level, there's actually a tag called the complex tag, right? You strip off this tag and you send the remainder to the complex arithmetic part. Now, because the data is complex number, it will now contain a tag that tells you whether it's rectangular or polar. So again, your generate operators over here will strip off the tag and then send it to the right operators, either polar or rectangular one. Okay, and after that, basically you go up the chain and you put back two tags, polar and complex. Okay, so basically what we do now is that we'll do this using data-directed programming instead of dispatch type. Okay, so this is how the code looks like. Okay, so essentially you have all these functions which you have seen before, right? Yep, and the difference is here. Okay, for these constructors, we basically get the constructors from the table as well. Okay, and we apply to x and y. Okay, or r and a. Now, so what we do then is that we basically add all this arithmetic, right, to the table. Okay, so now we attach a complex tag. Okay, and if it's add, right, it's lambda z1 z2 add complex z1 z2. So where is this add complex? Well, it's in the previous page, right, over here. So we are doing the same exact thing as we did in the previous complex number thing. Right, now we're going up one level higher. Alright, let's take a look at how the data will look like in this world. Now, this particular picture here will be an example of a data. Alright, and now there are two sets of tags. There is a rectangular tag and there's a complex tag. Now, why are there two tags? Well, it turns out that this is the picture here, and we need one set of tags at this level. Okay, so when we look at the data object, we know whether it's a rational number object, a complex number object, or ordinary number object, right? But suppose if it's a complex number object, that means you're in this space here, right? You will need another tag, right, to tell you whether it's a rectangular representation or polar representation. Okay, so you have two sets of tags. Now, so this is a layered abstraction. Okay, it's a very important idea in computer science. Okay, and the idea here is that when data passes down a layer, a tag is added. When data is passed up a layer, right, the tag is stripped away, right? This actually is applicable to other areas of computer science and not just to data abstraction. In fact, this is a very important idea in networking. Okay, so when you do your transmissions to your wireless, everything, this is actually important. Okay, so this will be a much more advanced class, and you can learn stuff there. Okay, so let's look at this. So far, we've learned that we can add numbers of the same type, complex and complex. Okay, what happens if you want to add something that's different? For example, you want to add a complex to a rational. The answer is that you do this thing called coercion. Essentially, you force one type of data into another type. Okay, the basic idea is that there's this thing called the hierarchy of numbers. Okay, what does it mean? So essentially, an integer is a rational number. A rational number is a real number. A real number is a complex number, right? So if you basically want to do this addition, you can coerce a number of a lower type into a higher type. So for example, if you want to add a rational number to a complex number, what you do is you convert the rational number into a complex number and then add both of them as complex numbers. Now, it turns out that the reverse doesn't always hold. For example, you cannot convert 3 plus 4i to integer because integer is not a complex number necessarily, right? At this point, you should all be a little bit confused. It's normal. This is a very complicated topic, and what you've seen today is a little bit complicated. There's one new thing you saw, which is the star operation, right? But other than that, everything else is sort of things that you saw in the earlier class, and we're just using those things in a little bit complicated way. But okay, don't worry about it. In missions 11 and 12, right, you will be asked to implement this generic number package, right? Once you're done implementing this package, you will fully understand how all these things work. It is actually not a very difficult idea. It's just that implementation is a little bit complex. So after you muck around with the code in missions 11 and 12, you hopefully understand this.